Hey, AP Statistics, one last section, part from here, 10.1. Going to go through a full, putting it all together for the two-sample z-test for P1 minus P2, or the two-proportion z-test. The two-sample z-test for the difference of proportions, so assuming conditions are met to test the hypothesis P1 minus P2 equals 0. First, find the pooled proportion P hat of successes in both samples combined. Then compute the standardized test statistic this way. P hat 1 minus P hat 2, 1 is 0, all over, and then we have our pooled proportion in there. Remember, that looks a little different on your formula sheet where they've factored out P hat 1 minus P hat 2, and so it's out front, and then they have 1 over N1 plus 1 over N2. Find the p-value of the calculating, by calculating the probability of getting a z statistic this large or larger in the direction specified by the alternative hypothesis in the standard normal distribution. So it could be a greater than or less than. All right, our example problem here. High levels of cholesterol in blood are associated with higher risk of heart attacks. Will using a drug to lower blood cholesterol reduce heart attacks? The Helsinki Heart Study recruited middle-aged men with high cholesterol but no history of other serious medical problems to investigate this question. The volunteer subjects were assigned at random to one of two treatments. 2,051 men took the drug gemfibrozil, to reduce their cholesterol levels, and a control group of 2,030 men took a placebo. During the next 5 years, 56 men in the gemfibrozil group and 84 men in the placebo group had heart attacks. Do the results of this study give convincing evidence at the alpha 0.01 significance level that gemfibrozil is effective in preventing heart attacks? And then interpret the p-value in the context. So let's start this out. So we want to know, first of all, our null hypothesis would be that there's no difference. So our null hypothesis is that P sub G, that's the proportion with gemfibrozil, which that should say G, sorry, that's a typo, and minus P hat C, or PC, and that's not P hat, make sure we're doing our hypotheses in terms of parameters. So PC, which is the proportion that took the control group, took the placebo, equals 0. So our null hypothesis is that there's no difference. What we want to know is if the proportion was lower for those who took gemfibrozil. The proportion is, in this case, less than 0. If the gemfibrozil group had a lower heart attack rate, then this number would be less than that number, and so it would be less than 0. You could also write this PG equals PC and PG less than PC. That's the exact same thing as writing this. So where P, so it should say G, is the true heart attack rate for middle-aged men like those who take gemfibrozil, and P2 is the true heart attack rate for middle-aged men like those who took the placebo, alpha level of 0.01. So that's our state step, quite a bit to that. Our plan step, so this is a two-sample z-test for PG minus PC, and then we need to check the random condition. The subjects were randomly assigned to the gemfibrozil or placebo treatment groups. Notice there's no 10% condition. In experimentation, we don't need to do that. We're not sampling without replacement, we're randomizing into treatment groups, so no 10% condition necessary. And then the large counts, where so we had the observed number of successes, 56, and then the observed number of failures. By the way, successes here is heart attack, so that's, success is just, yeah, I guess that's not success, but that's what we call it. And then 1,995 didn't have heart attacks, 84, and then 1946. All of those are at least 10. I mentioned before that there is another way you can check this. What you can actually do is, and some books will do this, they'll look at the pooled proportion. They'll actually take the sample size times the pooled proportion, because remember, that's really, this condition is looking for n times p, but we don't know p, so it's okay here to use p hat. But it probably would be even better to actually use the pooled proportion to check that condition. So you would do n times the pooled proportion and so on. But you don't have to do that. So then finally so we have our two sample proportions, 56 out of 2051, which is about 2.7% of them had heart attacks, 4.1% of the that should say C. Sorry, another typo. That is the control group had heart attacks. And so our difference in proportions is 0.0141. Is that statistically significant? We'll come back to it. We have our pooled proportion if we put them all together. So on the grand total of heart attacks was 140 out of 4,081. And so that gave us our best estimate of what they're both equal to. And notice it's kind of in between those two. It's that pooled proportion. And it's 0.0343. And so if we plug that into our denominator to our standard deviation formula, we get our expected variability, and then that's our z-score, negative 2.47. So our observed difference in proportions was 2.47 standard deviations below what we would expect if the proportions were the same, assuming the null hypothesis is true. So continuing on with the do, we find what's the probability we'd get something that low. This was a less than test, and so if we do really normal CDF from, this should say, sorry, there's, I don't know, this copied over wrong. This is negative 1,000. I'll do negative 1E99 up to, and this should say negative 2.47 with mean 0 and standard deviation 1. You get that p-value from this. And you could write it just using a probability statement as well. And you can also draw a curve of this. So what do we conclude? That's a pretty tiny p-value. So because our p-value of 0.0068 is less than alpha, 0.01, we reject the null hypothesis. There is convincing evidence that a lower heart attack rate for middle-aged men like those who take gemcitabine than for those who take only a placebo. So found significant evidence, and this is exactly what like experimental drug trials look like. They randomize into treatment groups, and then they perform this type of significance test, and they want to find significant evidence that it is effective, and it's not just sampling variability. So then last part, interpret the p-value you got in part A in the context of this experiment. So assuming the null hypothesis is true, always start that with a p-value even now. Assuming H naught, p1 minus p2 equals 0. So there is about a 0.0068 probability of getting a difference in heart attack rate for the two groups of negative 0.0141 or less just by chance involved in random assignment. Okay, yeah, I guess sampling variability is wrong. It's the random assignment variability. And so that is our full significance test for a drug study like this.